I have a trash can, a plasma cutter, and a robot, and today I'm going to build CNC quality engine mounts for my 1961 Cadillac Coupe de Ville. You're going to love this. Look at that. Look at that. It's automated. Don't worry. I'll show you. It's going to be amazing. So let's recap. 1961 Cadillac Coupe de Ville. I want to go drag racing with this. I want to bring my friends, maybe do some land speed racing, not sure about that. But first we have to build the car. And so far, we've replaced the stock X-frame with a brand new mandrel bent chassis from MRC Fab, which I think is no longer in business. I'm not entirely sure, but I think the business got sold. If you guys have been trying to get a hold of somebody to buy hydro shocks, go straight through Miller Brothers, and then they'll send you to a dealer. I'm not sure what's going on with MRC Fab. I think Jimmy sold the company. At least that's what I've heard. Anyway, the car is a roller. We have a mock-up engine and transmission dangling in the car. We've already recorded one video about trying to build the motor mounts, and that just didn't work out because our intake manifold was so tall, it wasn't going to clear the hood, and therefore, without knowing where the engine had to go to clear whatever intake we were going to be running, we basically stopped. We hit a brick wall. So I got another intake. This one is from Sean's Custom Alloy out of Australia. It is a modular CNC machined aluminum intake that has 2 sets of fuel injectors, and it fits a conventional headed Big-Block Chevy, which is what Nelson Racing Engines is building for me. Now, those of you with eagle eyes noticed that the engine that I put in the car during that other video was just there for mock-up. It's empty. There's a crankshaft in it, but there's nothing else inside of that engine because it's actually not my engine. My engine is still at Nelson Racing Engines, and Nelson is waiting for me to tell him how big of a dry sump oil pan I can fit on it, and also he wants me to build the hot and cold side of the turbo system, mount it on this mock-up engine, send it back to him in California. They'll install it and complete my engine, dyno test it on their engine dyno, then mail it back to me. It's a very convoluted way to do things, but when the engine finally arrives here, my actual engine, it should be tuned fairly close to what I need to at least get the car going. In the meantime, I've got to mount this engine. This thing just was not going to clear the hood of our Caddy. And so, at the suggestion of Tom Nelson, we bought this from Sean's Custom Alloy out of Australia, of all places. It is a modular Big-Block Chevy intake with 2 sets of injectors. The big set will be on the outside of the runners right here. This is what we were running our methanol through. The other set down in the valley will run our smaller injectors with our pump gas. And because we don't have the injectors on top, we have all kinds of room that we didn't have before. And the only thing that gets close to the hood is this right here. That thing is just over the fenders. I don't know about the middle of the hood, if the middle of the hood goes up, but this could be close to working. We can't necessarily go any lower because the crank pulley is right there above the rack, and the rack is the lowest point of our chassis, so there is no going lower. We don't want to move the engine backwards because then you end up burying the valve covers, the fuel rails, the burst panel under the cowl of the car, which makes working on it a pain in the butt. And at this height, we have a good amount of room for turning the exhaust out away from the control arm. There's a lot of good reasons to put the motor right here. Like you can get to the bell housing bolts, like this is, but I don't know if this intake works. We're just gonna have to put the hood on and find out.
Dude, it's not even close.
Really?
Yeah.
Like how high can it go?
Like half an inch.
No way. Oh yeah, that clears, dude. Oh, wait. No.
What? What am I not seeing?
The very top bolt on the throttle body. It's there. It does clear. Yeah. As long as the motor doesn't go any higher.
You are going to pin this bad boy in addition to the factory latch?
I think what I'm going to do, because there's nowhere for the factory hinges to go, is I'm going to make the hood tilt forward. Well, that means I can keep working. I just screwed up the other half of this day. I was like, all right, well, we can't work on this anymore. Let's go work on blasphemy. No.
Dang.
Okay. So what I need then is a accurate measurement between the pulley and the rack, and that's my reference point with the hood off. No matter what we do in mounting, it can't go any higher than that, basically. All right, good news. Motor and transmission are now dangling freely in the car. They're approximately where they need to go. We have test fit the Cadillac hood. It's going to clear by the slimmest of margins, but it is going to clear thanks to our new intake manifold. We're going to lock the motor in place using parts from Trans-Dapt because that's going to speed this process along greatly. These are billet pillow blocks that are going to bolt to the side of our Dart engine block. They are then going to get polyurethane bushings and these laser cut brackets that will bolt to the side of it. The end of the bracket's going to get welded to the frame rail, and then we're going to gusset the brackets together. Essentially, you can mount the motor here in probably an hour. If you're real proficient at this, it speeds the whole thing greatly. And after that, it's just make a new transmission mount because the one that's in the car is not going to work for our Gearstar Turbo 400. So that'll be after this. I know these are probably oil impregnated and probably self-lubing, but I'm still going to lube the sleeves before I put it in there because, yeah, it's just going to make it easier. A little red grease here so that it doesn't go in dry because friction. Don't want too much friction. There we go. Boom, like butter. All right, so now I need some socket head bolts. I believe these take 3/8/16 coarse thread in the side of a Dart block, which means it's a 5/16 Allen head to work those bolts because they're countersunk in here. So we'll get that next. And then we'll bolt these to the block, and then we'll figure out how much I have to cut off of these in terms of the length to make them attached to our frame rails. You guys know Trans-Dapt because they're part of the same company that owns Hedman headers, hamburger oil pans. This company makes everything you need to bolt oddball things like a Chevy 4.3 liter V6 into a Toyota mini truck, or these cool billet mounts for Big-Block Chevys, which you're going to stick in your 61 Cadillac.
Oh, you're kidding.
That's all right. We'll make new ones. It's all right. We're so close, though.
It's probably the same on the other side.
It should be if we got the motor square. All right, no big deal. So what we'll do is we'll put a bolt on here, tighten it up, get it at the right angle, and then I'll just make a cardboard template to get from here to here, and then I'll use this whole thing as a template.
Mm-hmm. Hold on, let me get the other one.
Okay, got it? Yep. Just gotta snug it a little more. Okay, now those will stay up.
It's actually still removable thanks to the poly.
And then now I could just make a cardboard template from here to here, tape it to this, and then transfer it to metal.
And then you want to box these once we have it all made?
Oh yeah, we will definitely box them. Here's how we're going to build our motor mounts. This is nothing more than construction paper that you can get from an art supply store or online retailer. This is our Trans-Dapt mount. It was a little short, and once we had the motor centered, we measured. We needed 2 more inches of length here and 5/8 of an inch more length here. So all I did was put that on top of the paper, used my square, added the length there. Wow, my kids are partying upstairs. And then added my 5/8 of an inch right there. Connect the 2 lines. And then I will cut this out, punch the hole in it, take it back to the car, make sure it fits, and when it does, we'll transfer it to metal. Here is our template. Here is the finished product. Boom. Ready to go, ready to weld. Now, our motor mounts are pretty simple. They're just going to be cut out of 1/4-inch steel. This happens to be really inexpensive, hot-rolled steel. A lot of pickling on it, very hard to get off. But the point here, and the reason I'm showing you this bracket is, this is one side of one of the engine mounts. It's a very simple design. I could cut this on my vertical bandsaw. I could drill the hole on my drill press. I could get this done, and it wouldn't take that long. However, if I had a CNC machine controlling my plasma cutter, this could go a lot faster. But more importantly, I could pretty easily lighten this mount up. You know, if I wanted this same design in this mount, well, trying to do that with my plasma cutter by hand or making a fixture to guide my plasma cutter that I moved by hand, it would take forever. And it wouldn't be as clean as this. I made this mount, and it's already been TIG welded together on one side. I still have to finish the bottom of it. I made this using my plasma cutter, which is a Miller Spectrum 375 Xtreme. And obviously it's already been TIG welded together on one side. I got to finish the bottom. But I controlled the plasma cutter using this arc droid. Yeah, robot. This is aimed at people like you and I. Somebody who's working at home in their garage, somebody who doesn't have CAD/CAM software, can't program G-code, all of the back-end stuff that, you know, a professional grade CNC plasma table or CNC machine would use. We don't need to know that. The arc droid can use a cardboard template that I cut out, which is how I made this. There's my Gen 1 template. There's the result. The arc droid can actually trace this, turn it into code inside the machine, then take my plasma torch and cut out a template that looks like this until I have parts that look like that. Yeah, it's just that simple. Essentially, what this is a robot. Inside this box is a wizard doing magic that moves the arm. I'm kidding. There's motors and gears in here. Essentially, this is an arm that's going to move forward and backwards, left and right. And yes, there's a Z-axis where this will go up and down. All of that in a traditional CNC plasma table would happen after you programmed some software in your laptop. Well, I don't know how to do that. The arc droid doesn't care that I don't know how to do that. This is a stylus right here. This thing is a stylus. This stylus allows me to take a cardboard template like this one. And I've discovered that using magnets are a great way to hold a cardboard template in place, right? If you can make a cardboard template like I have here of my motor mount, you can take the arc droid, trace it, and it will make an exact, or real close to it, duplicate. I'm going to lower the stylus down. And I'm going to come right here and click. And then I'm going to come over here to another point, click. It will automatically close the line for me. Then I'm going to come over here and click, and it's going to close that line. And oops, we've got a curved part. I'm just going to make a bunch of dots on this curved part. And the more dots I make, the smoother and rounder the cut will be. And then I'm going to come all the way over here and boom. Check this out. I purposely didn't show you the screen while it was happening because when I come over here, look at that. Everything I just did, it traced. Even the little whoop-de-doo I made there. I didn't program anything. I didn't code anything. Nothing. The touch screen is really cool. So let's just undo everything I just did, right? Let's just say that I didn't have a template, but I needed a rectangle for a gusset. And I wanted that rectangle to be, 5 inches wide and, 2 inches tall. Now look, I just made a rectangle, which is how I made this gusset. That gusset plate is just a pre-programmed rectangle in the box that all I did was put the numbers in to make the width and the length. And then I went in and traced that. It takes about 10 minutes to calibrate the machine, get it all set up. And the truth is this part of it is not the most intuitive thing, but There's excellent YouTube videos on the ArcDroid YouTube channel that will teach you how to use this. And the tech support is pretty incredible. I spent an hour on the phone with them just figuring out some more advanced things I wanted to do and some basic things that I didn't understand. And once you're ready to cut, you just come over here, remove the stylus, and then install your torch, hit run, and this thing will be burning metal with a quickness. Like, it's that good. Before we start cutting, let's go over our machine settings. This is a Miller Spectrum 375 Xtreme plasma cutter. It's a very versatile machine. It'll run off 120 or 240 volts. And switching from one power supply to another is as easy as unscrewing the MVP plug on the back of the cord and changing it. Right now, I'm running it off 240 single phase power because I'm going to crank this thing all the way up to its max setting of 30 amps. Because I'm cutting 1/4 inch thick hot rolled steel. And you'll notice on my particular machine, there is an extra plug on the back and 2 extra wires that you don't normally find on this. And that's because this is triggering the torch remotely from the ArcDroid. So you have 2 wires that come out the back of the ArcDroid. We figured out which 2 wires control the trigger in the torch of the Spectrum, and we just teed in line with them, ran 2 wires right out the back to a Deutsch connector, and these 2 wires coming from the ArcDroid are what's going to tell the Spectrum when it needs to turn on, when it needs to turn off. And so the connections here are clearly labeled torch. Beyond that, all you need is a compressed air supply, and so I've got an air compressor over here. Way overkill for what we're doing. You don't need nearly this much compressor. I chose the Polar Air compressor because it's relatively quiet and it has a lot of capacity. I believe that is a 65-gallon tank. No, that's an 80-gallon tank. And this is a max working pressure of 175 PSI. It does need 240 volt single phase input power, but it has a lot of flow. This will do 26 SCFM at 175 PSI. So if you have any really, demanding tools like an air-powered DA or something like that, this thing will keep up with it. It works pretty good for my blast cabinet too. Torch is set up, ArcDroid is ready to go. The trash can, and note that it's metal, that's there to catch as much of the debris and the slag coming off the bottom of the plate as possible. Now, someday, I think I'll probably build a water table for this, which would be nothing more than kind of like a kitchen sink that surrounded this and had water coming almost all the way up to the top of these vertical pieces that are holding our workpiece. That will do a really good job of containing the smoke and the debris and everything and keeping it from going upstairs and bugging my family. But for now, the trash can and the filter, that does a pretty darn good job of keeping my family happy and their lungs free of harmful contaminants. And the trash can's a little short. It could be a little taller, but I have a solution for that. I'm just gonna stack it on top of the first aid kit. And then later, when I need the first aid kit, I'll wonder where it is. But for now, the first aid kit is going to help my trash can do a better job of catching all the debris. You'll note that the torch is off. I'm just going to hit run and watch it go through the process and the motions of where it would be cutting to make sure that the torch isn't going to run off the workpiece at all. It shouldn't, because I traced it directly over a portion of the metal that, I was sure would work, but let's just make sure, shall we? Right now it's cutting out the slot in the middle of the part. And after it does the slot, then it'll cut out the circle, 1/2 inch diameter for our bolt. Then it will do the perimeter of the bracket. And the perimeter is where we need to really be concerned about whether we're going to run off the workpiece, because it is pretty close to this. I don't think it's going to get into it, but let's make sure. All right, so there's our circle. And now we'll do do the perimeter. And this is moving at about 14.5 inches per minute, which is about as fast as you want to go with this particular plasma cutter. If you had a more powerful one, then yeah, you could probably go a little bigger, a little faster. Okay, so here's the bottom corner of our bracket. This is the part where it would meet the frame rail. And I think we're gonna be okay here. All right, so there's our Trans-Dapt billet motor mount that bolts to the engine block. Here's the new mount I made to adapt the Trans-Dapt mount to the side of our chassis. As you can see, it fits good, it's ready to go. I just need to finish welding the inside of this mount. And I'll do that real quick and then bolt this in. Then we're gonna move to the passenger side of the engine, make a cardboard template, because that side is going to be a little different than this side because the steering's in the way. And then we'll make that other engine mount using the arc droid and the plasma cutter. Since the passenger side is done, time to build the driver's side. So we're going to switch from our torch to our stylus, and going back and forth is really, really easy. You can see I don't know how well it shows up, but there's the green dot. That's our 0 point. So now everything we do is based off of that. It's best to work inside out. So we're gonna do the inner cuts first, which is the hole for the bolt, and then the lightning slot. That way the machine will cut this out first, because if you cut the diameter of this out first, then the part gets loose. You don't want to go back and try to cut this. So we're going to program these two first, then move to the outside. Now, if you screw this up and you draw the outside first and then trace the inside, you can reverse the order of operations in the touchscreen. There's a button for that. But in general, if you just start there, it's a lot easier. And then we come back to our origin, or our 0, and boom. So I don't know how well you can see that, but let me zoom in a little bit more. But there is our first slot. Now when we're done there, we're going to double click, and you can either click the stylus or click this. And that means we have ended this, and you can choose, you're either cutting on the center of the line we drew, on the right side, or the left side. I'm going to do the right side because that'll be on the inside of that line. And then you can verify that by just looking, and it'll draw a little yellow line right there. Okay. Okay. Now, let's go to our next point. And we're going to cut on the right side of that line. Now, 500 is half an inch. That's the hole I actually want. But because we're cutting on the right side of that line, it would cut it a little bit undersized. But because this plasma cutter isn't going to cut a perfect circle, it's going to leave a little bit of slop in there, which gives us wiggle room when we go to install the engine. There's definitely more exact ways of putting a hole through metal, like a drill bit or, a laser, but this does work reasonably well. If you're concerned about having really tight tolerances, you could program it to just cut, say, a 3/8 inch hole and then run a drill bit through it. I'm not all that worried about that. So we will just stick with what we got. Now you can see as we trace over this, let's see. The little green dot, you can see it go as I continue to trace around this thing. And I'm going to spend probably 10 or 15 minutes tracing this whole bracket out. But then the arc droid's going to cut it out in probably 1 minute, maybe a little more. Now it's time to cut. There are a few drawbacks to using this, but it does solve a problem. You know, if you're working at home, and if you don't have a lot of room, and you don't have the time or the inclination to learn advanced coding or a new software, or you don't want to buy a bigger 4x4 plasma table, you know, and dedicate a portion of your garage to that, the Arc Droid is an excellent solution. There are a few hiccups with it in terms of the tracing function. That will take practice. You know, once you've practiced it and you figured out how it works, it's pretty smooth. It really is. The calibration, it's very basic and also easy to screw up. But once you understand how to calibrate it and, you know, the process for it, it's pretty quick once you've got it. It took me 10 minutes to do it, but I'm guessing now that I know how to do it and I know the sequence of events and the nuances of it, I can now do it in probably 2 minutes. I think for you guys at home, if you buy the Arc Droid, you're going to be up and running in probably an hour if you've never done any of this kind of work before. And of course, there's the investment of the plasma cutter. If you don't already have one, there's that expense. So if you're at home wondering, what does this cost me? Well, your Arc Droid is about $2,500. And if you've researched CNC plasma tables, you're going to notice right away that will get you a full CNC plasma table, maybe even with a water bed on it. So why grab an Arc Droid? One of the selling points of this machine is that you can just put it away in a cabinet when you're done with it. And also, the other thing is, if you're like me, maybe you don't have time or the inclination to learn CAD/CAM software. You know, maybe you don't want that. The Arc Droid is really aimed at someone like myself where you just want to trace a cardboard template. It's just that simple. So you're going to be in $2,500 on the Arc Droid. You need a plasma cutter. The Miller Spectrum Xtreme 375 that I'm using has no problem cutting through that 1/4-inch material that I used. And it's even better at thinner gauge material. That's about $1,800 right there. So you've got the $2,500 for the Arc Droid, the $1,800 for the plasma cutter. This is starting to sound like a lot of money until you realize once you get good at this, the time you save, you can't even really measure it. While I'm cutting out these motor mounts, I'm over here keeping one eye on it to make sure I don't burn down my house, because again, I'm in a basement, but I'm getting other stuff done. And that's really huge. The other thing is you can make more intricate parts a lot easier. I'm able to take those brackets, and they don't just have to be a solid bracket now. We can cut windows in them, more complex curves, things that if I'm manually trying to operate a plasma cutter would take much longer and probably not come out as precise. So in general, if you're in the market to automate your plasma cutter, look at the Arc Droid. It's pretty good value in my opinion. Here are our 3-piece engine mounts. Now, the plasma process is not perfect. That's a lot of P's. But if you look right here, you can see where when it pierced to start that cut, it went into the material. And then over here, you got a little more of that there. So not perfect. However, compared to what I would have done on a vertical bandsaw, cutting this out, which would have not been straight, and then attempting to straighten it on my disc sander, this is good. This is very good. Quick tip for you guys. Permanent magnetic chuck, a couple $100 on Amazon. It's like having a third hand. You turn it on, the parts don't move, and then you can sit there and grind and sand and whatever. Turn it off. You can flip it over, turn it back on, not going to move. Totally worth it if you're working by yourself. You need that. So you watch this. One-handed. Like it doesn't even matter. It's amazing. See? Don't stand up. Turn it on. Stands up. Science! Look at all the science. We got robots and magnets and trash cans in this episode. What you see here is the pickling, which is a coating on the steel to keep it from rusting and corroding. knock that off on all the surfaces that are going to be welded. And now we'll go over to the other table, TIG these together, and then weld them to the chassis of the Caddy. Here's a tip for you guys at home. If you want to perfect the spacing of your two brackets while welding them on a bench, just grab a piece of ball thread or a really long bolt, put some nuts on the inside and the outside, and then they will maintain the spacing of your bracket as you weld it together. Whoops, put the washer on the wrong side. Otherwise, you'll spend a bunch of time struggling trying to hold these things together, or weld stuff to it to hold it and keep it from moving. And to be clear, this is only going to dial in one side of the bracket, but it's better than nothing. Like that, too wide, so we're going to narrow it up. Still too wide. There we go. Boom. That'll work. Now we can weld. If you really want to get precise, you can grab a pair of calipers, measure the width of the bushings on the engine side of the mount, and then use the calipers to duplicate that here. And once you have it nailed, just tighten everything up. Double check. Yep, calipers still slide in and out. And now you can weld your gusset plate on there. There is mount number 2. That's the driver's side. Need to work on my edge control a little bit, but overall I am happy with that. That's 1/4-inch hot rolled steel welded with my Miller Dynasty 400 inverter machine. I used 3/32 ERS 702 filler rod. This is welded at about 220 amps, and I used my right foot to pulse this, not automatic. And it's welded top side, a couple stitches on the back side, and I think this is ready to go into the car. It stayed square too, I'm stoked. A little anti-splatter shield to keep everything from getting stuck when I MIG weld. This is from Walter Surface Tech. It is called E-Weld. Remember how earlier I told you I was using the trash can to catch all the debris? Look at that. Look at how much stuff was gonna end up on my shop floor or in the air and in my lungs. I could have swallowed that whole can. Damn. Trash can for the win. Version 2.0, water table. That would be the next move. And like I said earlier, it does need up much space when you're not using it. Just shove it under the table and get it back out the next time I gotta go crazy and CNC something. Engine is mounted. Pretty good job, I do say so myself. Got to use some new tools, learn some new things. Now, I know what you're thinking. Mike, why didn't you put a motor plate on the front of this? It's gonna have big power. Well, I didn't want to deal with the fact that the accessories are already mounted, the spacing is already set up, and I didn't want to undo all of that to put a 1/4-inch thick piece of aluminum between all those accessories and that engine block. Besides, I'm going to put a mid plate in here, and the mid plate, well, that's taking all the torque anyway through the dowels. So that'll be next. Get the mid plate finished and the trans mount done. And once that is complete, well, then we can start eyeballing where we're going to put the turbos in this thing, because I have those, which is good news. Now, you'll notice the intake is off, and that is because through a comedy of errors, I ordered one for conventional Chevy heads, which for me, that means not a spread port head, not a Big Chief Pro Stock style head. But in Australia, that means not a 20-degree Mass Motorsport head. These ports are raised. Our intake fits pretty good. The port alignment's not bad, but the bolt holes are off. So I've got to go here and slot all the bolt holes in this intake manifold before it will actually mount properly. And until I get that mounted properly, I can't start plumbing the turbo system. So these are not problems. These are just potential solutions. That's how we're looking at this. And we will keep on trucking and keep on making progress on the Caddy. That's it for this episode of Finnegan's Garage. Thank you for hanging out, especially those of you that went to fsmgarage.com and bought the merch, because your poor financial decisions involving your apparel allow me to make even worse financial decisions with the Cadillac. Stick with me. We'll have more on this bad boy.